Hello everyone, welcome to Sir's classes. This is Tushar Shaw, and in this video we will be solving the JAM 2020 JAM 2019 questions that we were solving since the last few videos. Okay, this would be the last video for the MSQ type questions, as there are only 5 questions left. Okay, so without wasting any time, let us start. Okay, so the question number 36 is there. It says the correct statement about NO2, NO2 plus, and CO2 are. Okay, the correct statements about NO2, NO2 plus and CO2 are. Okay, so we have to look at the each option step by step and check whether the option is true or not, correct or not. Okay, so it says that the first option says that both NO2 and CO2 are paramagnetic, but that is not the case because CO2 is diamagnetic. Okay, CO2 is diamagnetic and therefore NO2 is paramagnetic. Okay, I am not showing the vital diagram over here. You can just Google it or consult any standard books over there. You will see that NO2 has leftover pi electrons. Well, you can just look at the valence number of valence electrons, then you can determine whether this would be having an unpaired electrons or not. Okay, N has for 3 valence electron in the p and the 3 electrons in the p orbital. O has 4 and this has the 2 O has 4 so 5 electrons 5 10 total would be 11 electrons. So among the 11, 10 would be paired up and one would be left as the unpaired electron, and in this case the NO2 plus there would be 10 electrons and 10 of them would be paired up. Okay, and CO2 also is CO2 is also is the what should be said is diamagnetic in nature, because C has 2 electrons in the p orbital. O has 4, the 2 O has 4 that is equal to 10. So 10, obviously 5 pairs would be there, so this would be diamagnetic as well. Okay, so option B says option B says NO2 is paramagnetic and NO2 plus is diamagnetic. That is what I explained just now. Okay, so this option is correct. Option C says both CO2 and NO2 plus have linear geometry. Well, the geometry, let us look at the geometry. Okay, so CO2, yeah, so what is the diagram for CO2? We have this. Okay, now here that what happens is that C has total of 4 electrons. Yeah, 4 electrons in the outermost shell, that is the two or the second or by the second period. Okay, so here and the double bond O does not count. Okay, and in the case of NO2 plus, N has 5, but there is one plus sign, so N has now also 4. Okay, so this is the structure of NO2. Both of them has linear geometry. Okay, so C is also is correct. And when we look at the option D, it says CO2 and NO2 plus are isoelectronic. So we have calculated over here, 10 is there for NO2 and 10 is there for NO2 plus and 10 is there for CO2. So this option is also correct. Okay, so the correct options are the option B, option C, and option D. Okay, moving on to the next question, that is question number 37. We have uh, the compound formed as an intermediate in the following sequences, following reaction sequence are. Okay, so 5 reaction is given with 5 sets of sets of reagents. So we will be firstly writing on the whole mechanism of the reaction, whole product of the mechanism of the reaction that is going on. Okay, uh, instead of this circle we will be writing it like this. Okay, yeah, so first step, we have given LiNH3 and THF. Okay, so Birch reduction is taking place over here. Birch reduction. Okay, now in the presence of the OMe, that is a electron donating group, this kind of intermediate is formed. Okay, Me, OMe. Okay, now we give O3 MEOH. Ozonolysis occurs, one of the double bond breaks into 2 double bond O's. Okay, so this one would break, um, giving us double bond O. Here it is OMe, here it is this one, and OMe. Okay, this one would be formed. Now with in the next step we give NaBH4 ETOH. Okay, NaBH4. So NaBH4 would reduce this double bond O, this aldehyde group into the alcohol group. Okay, so ONE would be here, and um, yeah. So OMe and the reaction and the Me would be here. Yeah, and this one would be CH2OH. Okay. Uh, Here would be OH. Okay. So this would be the second third last step. In the second last step, we give TSCl, that is tosyl chloride, with pyridine. Okay. So what would happen is this OH will be replaced by OTS and HCl would be removed from the system. Okay. So OMe is over here, this is the double bond, this Me is over here, and here we get OTS. Okay, and in the last step we then give LiAlH4. Okay, so what happens is that this OTS is removed and H is added, and this group is also like substituted to O, this is obviously methyl carboxylate group, but it is converted into the alcohol group. Okay. Mm. This is a methyl group, here is also a methyl group, the double bond will be there as it is, and here OH will be formed. So this is the product that is given in the question. Okay, now in the option A intermediate is formed over here, the option D intermediate is formed over here, and option B intermediate is formed over here. Okay, so option A, option B, and option D are formed. Okay, so option A, B, D are the correct options. Okay, moving on to the next question, that is question number 38. Okay, this question says secondary structure of a we have to just read and check whether the questions are true, like correct or not. Okay, so where's the pointer? Yeah, so option number A says secondary structure of polypeptide describes the number and the type of amino acid residues. So this is false, obviously, because the primary structure does that. Okay, the option B says uracil is a pyrimidine nucleobase. Okay, yeah, so this is correct because T, C, and U are pyrimidine. Okay, and except for these, A and G are purine. Okay, so U is obviously a pyrimidine, so this is the correct option. Okay, in the C option it says natural fatty acids have odd number of carbon atoms. This option does not make any sense. Okay, the fatty acid the fatty acid molecule has no consideration of odd or even number of carbon atoms. Okay, so option number D says reaction of D glucose with CaOH whole 2 gives a product mixture containing D fructose, D mannose, and D glucose. Now this is a legit reaction because if we want to convert it into the let us say the any carbohydrate into its anomer, we use CaOH whole 3. Now this conversion which is taking place does not give any one product but a mixture of products. So this reaction, this statement is correct. Okay. Okay, so the answer for this option for this question is option B and D. These are the correct options. Okay, moving on to question number 39. The diastereomeric pair among the following options are. So the option A is, let me draw the options, H, PH, and Me, and here is PH, H, um, Me, ET. Okay, so these are cis and trans isomers. I have already told you in my stereochemistry classes that the cis and trans isomers are diastereomeric. So this is one diastereomeric pair. Okay, now uh, the next which is given is Br, Me, and tertiary butoxide. No, not tertiary. Is it tertiary? Yeah, it is tertiary. The structure is very small. Okay, Br, Me, and tertiary butane. Now, this is a cyclohexane ring. Okay, so we might be considering the chair form. Now, as the tertiary butoxide ring, tertiary butoxide group is there, so the no flipping would be taking place. The molecule would be rigid, that are, and an ancomeric system would be formed. Okay, so in an ancomeric system, the molecule is rigid, so no flipping is possible. So by anyhow, these two, like by flipping, this molecule cannot be converted into this molecule. So these are just diastereomers. Okay, so this is also a set of diastereomers. Now, in the option C, you can see that this one is OH and here it is Br, and in this case you have OH like this and Br like this. Okay, so you just take this molecule and rotate it this way, you will be getting this isomer. Okay, you will be getting this isomer. So these are homomers. Okay, these are homomers, these are not diastereomers. And the last option that we have, that is option number D. um, This isomer is obviously diastereomers. Okay, because same case for the, as I have explained in option number B, that is let me first draw. OH is over here, OH is over here, and OH is over here. Okay, so in the both the cases you can see that the difference is just in the axial and the equatorial positions of one of the OH groups. Okay, so this cannot be obtained by flipping or anything. So so these are diastereomers. Okay, so the options A, B, and D satisfy the condition for the question that is given, that is the diastereomeric relationship must be present, and therefore option A, B, and D are the correct options. Okay. Moving on to the last question of this video, that is question number 40. The reaction that results in the formation of aromatic species. So let us write down the reaction step by step. We have plus SbCl5 gives plus, and SbCl6 minus. This species is aromatic because 4n plus 2 rule, 5 electron rule is followed over here, so this one is aromatic. The next in the next system, what happens is Br, we give AgBF4. Okay, so AgBr is formed obviously. BF4 minus is ion is there, and the organic compound is like this. Okay, so here Br minus is removed, so plus charge will be formed. Now this species is anti aromatic. Okay, so this is not aromatic. In this case we have pH, sorry, COPH, and we have pH over here. Okay, now if we give NaH, what would happen is H minus would take up the H, 1H from here, and a minus charge would be formed over there. Okay, pH, and here it is COPH. Okay, now this in this ring obviously you can see that if plus charge is from the in the cyclopropyl ring, then it is aromatic, but here it is minus charge, so it is anti aromatic in nature. Why anti aromatic? Why not non aromatic? Because resonance delocalization is still taking place, but the 4n plus 2 pi rule is not followed only. Okay, so the last option that is there, um, we have this one where we give Na. So what forms is a minus charge is formed over here. Here it 4n plus 2 pi rule is followed. Okay, so this species also becomes aromatic, and Na plus would be the byproduct. Okay, so option A and option D gives aromatic products, and therefore option A and option D are the correct options. Okay. So thank you guys for this video. We'll on the next video we'll be starting the NAT questions, and that would require probably 4 classes, and then we'll be finishing the JAM 2019 set of questions. Okay. So thank you.